Hi everyone, it's Ian Kian.
In this video, we are going to demonstrate the continuous distillation process in packed column of methanol in water.
Note that this is a binary distillation as there are two components involved, which are methanol and water. Let's start by looking at the working principle of continuous distillation.
So, what is continuous distillation?
Continuous distillation is a process to separate miscible liquids to their constituent components by utilizing the difference in their boiling points. Thus, the aim of this experiment is to separate methanol from water.
The component with a relatively lower boiling point tends to have a higher volatility. Methanol at atmospheric pressure has a boiling point of 64.7 degrees Celsius, which is lower than that of water. Hence, methanol is the more volatile component in this case.
Distillate and bottoms are the products of distillation at the top and bottom of the distillation column. Distillate will have a higher compositions of more volatile component, which is methanol in this case. A small amount of water could still be found in the distillate. Whereas for the bottom products, it will consist of mainly water, which is the less volatile component. Similarly, it will have a small amount of methanol in it.
In general, distillation could be carried out in black and packed columns. And generally, a continuous distillation column can be separated into two sections at the feed point. Above feed point, it is a rectifying column with a total condenser on the top. Below feed point, it is stripping section with a partial reboiler at the bottom.
In black column, plates provide contact between rising vapor and descending liquid. For example, the liquid flows across the plates, while the vapor is in contact with the liquid by rising through the openings in the plate. The mixing between vapor and liquid streams enable rapid mass transfer to take place.
In an ideal situation, the streams leaving each plate are in thermodynamic equilibrium. However, in reality, both streams leaving the stage are usually not in equilibrium.
So what about passing streams? Are they in equilibrium?
No, the liquid and vapor stream passing through each other are not in equilibrium. We usually assume that the flow rates of liquid and vapor streams within each column section are constant. This is often referred as constant molar overflow.
However, as there is a feed into the column, the vapor and liquid flow rates across rectifying and stripping sections might not be identical. In this demonstration video, we will be using packed column instead of plate column.
At the bottom, there is a partial reboiler which vaporizes a portion of liquid leaving the distillation column to form saturated vapor. The saturated liquid which is not vaporized will be drawn off as bottom product. Here, we can define a burnout ratio, which is the proportion of the flow rate of saturated vapor to that of saturated liquid.
The packings in the column allow rapid mass transfer to take place between countercurrent vapor and liquid streams.
Above the distillation column, the total condenser condenses all the vapor, which is mostly methanol vapor, into saturated methanol liquid. The condensed methanol liquid is our distillate. A portion of it is returned to the column as reflux, and the rest is produced as top product. The flow rate ratio of reflux to top product is known as reflux ratio.
We can determine the minimum reflux ratio for the column operation using Underwood's equation. In practice, the actual reflux ratio is usually 1.1 times of its minimum reflux ratio in order for distillation process to function well. Overall, reboiling and reflux are necessary to create countercurrent flow. We can plot operating lines for rectifying and stripping sections after knowing the compositions of distillate and bottom products. For plate column, with operating lines and an equilibrium curve, we can carry out mechanically graphical construction to determine the number of theoretical stages for distillation.
Similarly, for packed column, we could determine the overall gas phase mass transfer coefficient with known packing height through further analysis. Don't worry, this will be taught in later stage of your course. Remember that partial reboiler in the column is counted as one theoretical stage. So, this is the end of our video. We hope that you have gained a better understanding about the principles and operations behind the continuous distillation process.
Thank you for watching.